Okay, hello everyone. Good afternoon. Uh, okay, so are we decreasing in numbers? I didn't see many students now, but that's okay. Maybe they came late, or maybe having another agenda, but maybe. But what I would like to try to do today. How was your classes last week with your TA? Okay, with your TA. I think she give you some exercise, right? Or no? Actually, as I mentioned, if you are maybe if you make request to your TA to make another TA class, you can do that as well. But you need to mention to the TA. You need to ask her whether she can provide additional classes, for example, on Saturday or not. So it's not tutor, TA. TA also can be done. So you need to ask your TA if you want, maybe for another hour or another 2 hours. But you need to ask the TA like maybe 2 weeks before or 1 week before. And I think she also would like to ask whether the classes need more or not, because she needs to prepare the classes. Maybe need to check which classroom that she could make, and it's like optional. It's not really required for everyone to join, but the one I think students who need the most is the one are maybe who wants to catch up some content that maybe the students maybe having some problem with that content. Okay. And then also I think some of the tutoring groups have already in works, but I think other has not been started yet. And yeah, I think either if you need like tutoring, you can ask the group that already in works now if they have still like maybe 1 or 2 students can join in. If the tutors allow, then you can join the groups. If not, maybe too many, maybe you need to look for another one. And actually, the one who looks for tutor is not me. Actually, the students who need to look for the tutor by themselves. I just want to help you. Okay? So the original way, the method is you are going to look by yourself. Maybe some seniors asking how his or her score, and then whether they can teach the student or not. That's actually the way. So actually, it needs to be done by the students. But since you are freshmen and I think you don't really know how the policies, so I would like to help you by assigning some students into some groups, and then you can. I try to make the groups, the levels are similar, although maybe not ideal, but I hope that is okay, because if there are too many gaps between the students themselves, the tutor will be difficult to give some instructions. Okay? So that's my point. Okay? So last time with our class, last 2 weeks, we've discussed this part, right? Have you tried number 57? Have you tried this one? Okay. It seems like really big chunk problem. It has like a blah blah blah, and then probably some of your mindset says that this will be difficult. But I'll give you some clues how to solve problems like this. Even it's giving you some hint. So we can read these sentences. Okay. So instead of finding blah blah blah, then we can set the f of x and g of x as the top equation function and the denominator one. Okay. So this is f, this is g. So instead, we take this and then do the quotient rule, which is very, very bad, right? Imagine that we need to square this and then Wow, right? So instead of doing that, the hint says that we can compute this using this separately. Okay? So we have f. So what does it say is we are going to imagine that this is going to be f, this is going to be g. Okay? Of course, if we put 0, we can compute both equations, right? We can compute f of 0, which is 0, and we can compute the g of 0, which is 1. Okay. And can we derive f? We can, right? So let's just review and check whether you can derive this or not. So let me write here f of x is x minus 3x cubed plus 5x power 5. So let's try derive. So we got what? 1, and then minus 9x squared, right? And then plus, over here I didn't hear sound from here, 25x4, right? Okay, so let's write that part. Okay, so this will be 1 minus 9x squared plus 25x to the power of 4. And then g. Okay. So I'll do the same thing. 1 becomes 0. This same, right? So 9x squared plus 36. X to the power of 5, and then 81 x to the power of 8, right? Okay, so I just write that. So this will be 9. Okay.
There, and the plus 1.
Which?
At the front of the x.
Yeah, what is that? Why? What is that? What's happened? Do you know what? Yeah, do you know what? Yeah, what's happened?
As I'm asking you, what about?
Yeah. Can you answer this question?
Oh, okay.
Okay, now we want to make the R. So let me write here that, let me change color, maybe blue. So R is actually F over G, right? So if we would like to take R prime, okay, we take the quotient rule, right? Okay, what should we write here? So of course the bottom side will be the G and then squared, right? What will be the top equation? F prime
times
G
plus
minus. Okay, good. Okay, I will write F prime, okay? F prime G minus G prime F, okay? Okay. F0, 0. G0, 1. What is the question actually? The question is actually finding the R prime 0. Okay? Finding R prime 0, which means we're going to put 0 here, right? Exchange all the x with 0. So the F prime 0, let me put this a little bit. Oh, sorry. I mean, when I want to move this over there. So F prime 0 will be 1, right? We put 0 and everything with x going to be 0, right? And then G prime 0, we put x equals 0 and everything will be 0. So it's just 0. So R prime 0 will be F prime 0, which is 1. Okay. This will be 1.
G will be also 1, right, from here. G prime is 0. So for obvious reason, this whole thing will be 0. And G of 0 is 1. So what's the answer? It's 1.
Okay. So, yeah, this could be simplified as that. So, it could give you some analogy that sometimes when you think like a big fractions like this, perhaps you think at the beginning you would like to, oh, we need to take this square, blah 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 blah. But you need to specify what is the purpose, what is the question. So if the question is asking the r prime 0, which means we are going to focus on finding how to get this x equals 0 inside the derivative of this function. Okay. So we can separate this and then we play a little bit with the quotient rule. Okay. We make the top equation as a function, the bottom as a function, and we compute each function separately. Okay. And then we combine all together within this. Okay.
So this will be equal 1, right? Okay.
Yeah, I'm just make sure that the quotient rule and then the derivatives, like from the power rule, we already have some set of
Knowledge beforehand, okay? Okay. Okay, any question before? So I will start with a few questions and then we go to the next part. Okay, now this is have been done. Okay, now how about this? Okay, especially the
61 and 62. Maybe 61 first. D 99. It means you need to find the 99th derivative. So first derivative, second derivative, blah blah blah, 99 derivative. It seems like a lot of work that you need to write 99 times, right? But of course, it doesn't need to be like that, right? Okay. So the interesting part on this question is these trigonometric functions. Okay.
So if we take for example, the sine x, we take the sine x like that, we get cosine, right? Or maybe let me write f prime, or maybe if fx is sine x, the f prime x is cosine, right? And the second derivative will be what? Negative sine, right? Okay. And then again, the third derivative, what will be? It's the same as the previous one, but we add negative, right? Negative cosine x. And the fourth time, what will be? Sine. So it's going back to the original one.
So how many times? After the fourth time deriving these functions, we get back to the original one. Okay?
So if we know the patterns, the question is what? 99, right? So d 99, dx 99 of the sine x is equal. So if we play with the numbers 99, if we divide by 4,
because we know that 4 times is getting back to the original one. So if you divide by 4, 2, 4, 20 to 24.
At 24, right? At 20, 24, is that 96, right? 96. So if we divide by 4, so we could take this 4, 24, this become 96. And we need to add the other 3, right?
So the derivative of 96 will be sine x. Okay, and then plus 3. 1, 2, 3. So the answer is negative cosine.
Okay. So the answer will be negative cosine x. Okay. Okay.
So based on the pattern, we could get the answer. Similarly, you could do the same thing with this number 62, but with some complexity, which includes the product rule of the x sine x. Okay, any questions? Any question over there? Discussing about what? No? Okay. So this is actually some problems that can be solved using some patterns in some pattern.
Okay, I hope you try number 62 by yourself, but the idea is you check some patterns. Let me just give you some rough idea here. So you start with the x sine x. So let's say the f of x is x sine x, and maybe you could write another functions that is just sine x. So the f of x you could write as x h, okay, or as h of x, okay, just to simplify the sign. But I think if you doesn't need the h is also okay, then you could focus on the x sine x. So what will happen here is you have x h, which if you derive this, you will have the product rule which has two components plus, right? So let's just try several terms. So let's try the f prime x. Maybe different color. F prime x will be, this is h x plus x h prime x, okay? And then try the second one, try the second derivative, h become h prime x plus this one becomes, and you need to be consistent and careful in your writings. So this will be h prime x and then plus x h double prime x, okay? And then you see that we can combine this all together. Then we can write as 2 h prime x plus x h double prime x. And then let me try several more. Why he's include here. Maybe make it smaller. And then the third derivative. So 2h prime x, it's become 2h double prime x plus, again in this part, we have x h, or maybe let me start with the h prime double prime x plus x h triple accent x, okay. And you will see we get now the 3, okay. Do you see the pattern now? Maybe try one more. Maybe once more. Maybe the fourth time. So 3h triple prime, we get 3h 4 time derivative plus this will be h triple prime, right? Is it correct? H prime and then plus x h fourth. Is this correct or no? 3 3h. It's my let me erase this first. Okay, I think it's correct, right? Okay, so 3 so xh4 plus h3x. Okay, so what else? Okay, so we can get the general formula for this part is n h n minus 1 of x plus x h n of x. And you could try with another derivative and check the result. Oh, I made some mistakes. So this should be 2. This should be 3. That's why I feel it's a little bit not really connected. So this should be 4. Okay, plus x h 4x. Okay. Okay, now it's clear. Okay.
So we have these factors, and we can set some formulation for this factor, and then we can mapping the functions x sine x into these functions. It takes some time because it's not a typical question that you need to maybe answer in a matter of maybe small time, but you need to think how to define the structure first, okay? And then to map out the x sine x within the functions.
So if we take the 35 times, so we want to take this 35 times, and we know that if we have 34, okay, this is going to be, because we know that every 4 times the sign will be back to sign, right? And we have this also sign in one part of the components. So 34, if we divide by 4, this is going to be 4, 8, and then we do plus 2, right? So after sine, cosine, and then negative sign, right? So we have this will be the h if if we take the 35, then this will be or maybe I think we can do directly here, 35. So just plus 2, plus 3. So sine, cosine, negative sine, and then negative cosine. So negative cosine, right? Negative cosine x. So the dx 35 of x sine x will be 35, and then or maybe let me write using this structure first. So 35 h 34 of x, and then plus x h 35 of x. Okay, if you're confused about this, that's good. It's I think it's worth for a typical question in exam. So this will be 35. H34 will be, so plus 2, it's the negative sign, right? So negative sign plus x, and then H35 is negative cosine. So this will be the answer. Negative 35 sine x, negative x cosine x. So this will be the 35 derivatives of this function x sine x. Okay. Okay. So a little bit messy, but I think this is the point on exam. It's not about your calculation, but it's about the process and how to find that, and how to find the patterns, how to solve the logical questions that is usually given in the information given in the question. Or I write before, but why I'm erasing it? So age 34. Just to give you a context here, that this is from that point. So what about this part? This part is telling you this every 4 times, it's back to the original one. So you need to plus how many times that you are going to have at the end. Or if you need the 34, then you need to take the 34 and then plus 2. And then you can just remember, like of course, this is something that you don't need to memorize, okay? Please don't memorize this, okay? What you need to do is, you know how to derive sine. You get cosine. You get, after that, you get negative sine. You get negative cosine. That's the thing that you need to know. And then, from that perspective, you build the pattern, okay? We build the pattern, and then seeking the pattern, and then try to include all the patterns within all the process. Okay. Anyway, that's just a little bit intro, just to make sure that you check the questions. Okay, you check the questions. I think I mentioned in the notes. Try this part. Okay. Have you tried? I don't think so, right? But that's okay. But can you try number 63, but on your own, okay? Not in class. Number 63. Like all these questions, the 61, 62, 63, they are all worked as a exam questions. So yeah, based on what we have in the exercise, you need to ask yourself, okay, what I've been missing. Okay? You need to ask yourself, okay? Because even though, like, although I provide tutors, we have TA, they cannot, they couldn't fulfill your needs. I'm pretty sure of that. But you need to know about yourself. Okay? You need to ask the right question, and then you get the right answer. If you can't find the right question for yourself, like what is your level, you need to answer that by yourself. Okay? You need to find your own way. Your tutors couldn't help you, even though like I'm pretty sure tutor will help you, blah blah blah. No, they couldn't help you at all. It depends on you. Okay, it depends on you. Okay, I think we can move on to the next section. The next section is actually it's supposed to be implicit differentiation, but I would like to go to the logarithmic first before implicit, because I think I will finish all the function of variable 1. Then we can move to the implicit. But maybe you are asking what is implicit. Later we are talking about that. Okay. Okay, let's start off the logarithmic. Okay. Okay, remember that we start off telling you the exponent, which is usually we take the b with power of x. Okay. The log. Okay. We can write the log as, or let me write this. The exponent is the inverse of the log. Let me write y log bx. So if we somehow draw the exponent, so if the exponent may be maybe around there, and it must be crossing the x equal 1, y equal 1 there. Maybe it's not quite exponentially, maybe about that part. So the log is actually around here. Okay, so it's going to be here. So remember that the inverse will be mirroring with the y equal x line. So this is y equal x. So let's say if this is b with power of x, this is the log with base b of x. Okay. Now we would like to know if we have this log. Okay. Can we derive this, and what would it be? This exponent here we have done before. When we derive, what's the unique property of the exponent? Anyone remember? We are going to see this every time we derive, especially with e. E with power of x, we derive e power of x, e power of x. And you will see later, if we take some courses related to either statistics or maybe more advanced mathematical course, you will see that this exponent will help you a lot to solve most advanced mathematical problem like differential equation. Because when we deal with that, we derive, we integrate, we are going to see e, and then e again, and then e again, and maybe we can make some manipulation from that part. Okay? So that's really interesting. But for b, we are going to see if we differentiate this, we're going to have b with power of x multiplied with l and b. Okay? Okay. Now how about the log? Okay. So to get the idea, if we let y equal log base of x, so then if we convert this to the exponent, then we have b with power of y equal with x. Now I understand why implicit need to be introduced. Okay. So from this part, we are going to try to derive this. But to derive this, let's jump for a while to the implicit differentiation. Okay. So, and then we go back to here. So let's jump a little bit. Jump. Where is the? Let me check. Okay, let's jump for a while to here, and then we go back to the logarithmic later. So what's implicit means? Implicit. Okay. We have implicit, explicit. So implicit is you say something that directly, not indirectly. So what's the example? Okay. If I say, okay, this is the microphone, then I say it directly. This is explicitly explain that this is microphone. I say, what is something that you use to enhance your voices, to increase your voices? What is the tools, blah blah blah? Well, it's referred to the microphone, but it didn't say so. It doesn't say directly. So we say it implicitly, or something when you are usually maybe people doing this, like you say something not directly to that person, but you're actually maybe you are gossiping on someone, and then you use some codes. That person, blah 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 blah. But you don't want that to be heard by that person, then you need to use some codes. And that's implicit. Okay? So what this actually really means in our differentials. So our goal in implicit is, for example, if we have a, let's say, x squared plus y squared equal 25. Okay, we know this is an equation of what? Circle. Right? It's a circle. But it has this y squared. So we are, maybe you are not curious, but mathematicians, they are curious how to derive this. Because we have x and we have y. Okay? So how to derive it? So if we take the derivative here, how, right? If we, one way is maybe we are making this become one side like a function, normal function like this, and then we get the y is having a square root, right? We have a square root plus minus, don't forget. Okay. So maybe if we take this, derive, like we have dy dx, right, as usual, and then the 1 over 2 square root 25 minus x squared multiply with the negative 2x, right? Maybe we could done something like this, but we want to go directly solving this x squared plus y squared equals 25. Can we do something about that? So if we try to visualize what we have, this is the circle equation, right? But if we try to make it into this y, okay, it's a normal function with the square root, we have these two curves. We simply, we have split out this circle. But what we want is, we want this full circle. Can we do something about that? Now this is what we call the implicit differentiation method. Okay, so the idea so this implicit, first we need to assume or assumption that y is still function of x. Okay, we need to make sure that this y is function of x. So this x squared plus y squared equal 25. So if we take this and derive, let me put one by one. This becomes 0 on the right side. Okay. Okay. Now the problem is, I think the problem is the y squared, right? So let me write here just to make the notes. How to derive this y squared? Remember, y we assume as a function of x. Okay. So let me write here, y is function of x, which means we can write this in terms of the chain rule. So we can write d dy, okay, y squared, and then multiply with dy dx. So it's the same thing, right? It's the same thing.
But when we try to make this d dy y squared, this thing we could just write 2y. Okay. So the whole thing for the y squared,
This become 2y dy dx.
for practicality, to be precise, so that you don't really confuse about how to do it in practice, whenever you see y, every variable you see y, and you want to implicitly differentiate that, at the end of the result, you can add dy over dx. But what we are doing is practically the same thing with the x. We just add dy dx at the end. Okay? Why this happening is because we make it into our chain rule. Because we know that this is actually a function of x that we could combine with the chain rule. Okay?
So this whole thing, this one here, it's become 2x plus 2y dy dx, and then equals 0. And what is our goal?
What is our goal? Let me think. Why we are doing this one? Our goal is we are going to find this. So the expression of dy of dx is appeared inside the equations that we need to solve. So we are just solving the algebra and finding the dy dx.
So dy dx so let me just write 2y and then minus 2x, and we can cancel this 2 part. So we have dy dx is negative x over y.
And then maybe it's asking some slope, tangent, blah, blah, blah. The idea is still the same. Like you did before, finding the tangent line, blah, blah, blah. Right? The idea is finding the slope, check the point, and then involving the point in the line equation, and then you get the line equation. But now we have implicit differentiation. So perhaps if you see any equations that involve y inside the equations, now you can use the implicit differentiation. Okay?
Okay, what will be if we have, let me give you an example. Okay. Let me give you example. I think we're gonna have a break. Okay, so let's back to this part here.
Okay, so now we have this problem here, which is, of course, you see, every time we see equation, and we have y inside the equation, and always we assume that y is function of x to be, so that we can solve this using implicit. So the practical way, we treat all x and y like this a normal function. It's like a normal function of x. So x cubed,
I think we agree that this will be 3x squared. Okay. So let's or maybe let me write again, and then we take derivative with respect to x.
so the implicit part is from y. We know the x cubed explicitly is become 3x squared. But for y, because it has relation with x as a function of x, you can treat the y as x, but not really direct, like you gossiping with your friends.
So what we've done here is taking this just like x, but we add dy dx. Okay, and then do the same thing with the 6xy.
And because now we have two entities, you can imagine this is function A, function B, or f, g, and then you can treat like a product rule.
So this will be 6, okay, and then differentiate x, and then we will have y plus x, and then dy dx. And then what's next?
Next thing is we are going to solve the algebra. Okay, we are going to solve and find this dy. So we are going to group this with this dy dx. Okay, group this so we have some
Computation for a while, we calculate. So we can write 3y squared dy dx minus 6x dy dx equal 6y minus 3x squared. And then we can continue over here. So dy dx is 6y minus 3x squared divided by 3y squared minus 6x. I think if you want to stop there, still okay. Or if you want to maybe divide this, become 2, it's also okay. I will prepare like more exercise maybe next week for this part, but I will use this implicit for our logarithmic, okay, for our logarithmic proof. Okay. Okay, any question about the implicit? Okay. So actually, idea is still the same. If it works with x, it works with y too, but you need to add the dy over dx as a consequence from the chain rule definition of because y is also function of x. Okay, then, okay, we're going to go back to the logarithmic that we previously see from here, okay? Okay, now we have another component of y. And then what we are going to do is, because as I said before, we treat the y as x, like equal, but we need to add dy dx. So we are going to derive this. Okay. So what is b with power of y? We are going to have, remember that, let me write some notes here to get you remember. So if you have b with power of x, if you take the derivative, this will get you this and the L and B, right? So if we do the same thing with y, so we are going to have b with power of y, and then you have the L and B, and then you have dy over dx. And then what will happen with x? We derive becomes 1, right? So we can write in terms of dy dx is equal 1 over b power of y ln b. But we define the b with power of y is x. So it's actually our dy over dx is 1 over x ln b. Okay. And then our unique numbers for the base, we take e. Take e here, it will be 1. It will be 1 over x. So when you have the ln x, so for example, so if b equal e, then the ln e is equal 1. So we get the formula for the ln x is equal 1 over x. So every time you see any function in terms of log, and then this can be any function, like it can be x squared plus 1, blah, 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 okay? So any function here, so every time you see ln, we derive, we get 1 over that part, and don't forget, if we have the chain rule, we multiply with the derivative of the inside function, okay? Like cutting the onions. We start from the outside and then going inside. Some quick example. I have 2 examples here, or maybe 3. That's quite, I think, related to the chain rule as well. So the more content you have, the previous part, the method, is still need to integrate it, and then all the methods become one. So inside one questions, maybe more than one section of the courses, okay? So, example here, maybe first one is, maybe just find dy over dx. And maybe we need to define this. I think in your textbook they don't define anything in the example, but you need to define this as a function of x. Okay, to be clear. Okay, this is the function of x. So number one, y. Number two, I start from similar with your textbook. If you bring your textbook, you can see the example, 3 example over there. So the first 2 examples, start with the log function as the main, I think the main function, the outside function, and then you see the inside function, the x cubed plus 1 sine x. It's the inside function. You see the third one, the log is becoming the inside function. The outside function is the square root. So if you want to test yourself, you can try maybe let me write here so that you are familiar with the ln. So every time you have ln x, we differentiate, and this will be equaling to 1 over x. Okay. Okay, so the idea, every time you see ln, you want to derive, then the whole thing here coming down, so it's going to be 1 over anything inside here, and then multiply with the derivative of this inside. Try by yourself. You need to check. Like, if you like just see the mathematics notes or maybe some numbers, at one point maybe you feel, okay, I understand. But you didn't try to write, you didn't try to check. Sometimes that will make your judgment biased. Okay? Do you understand what I mean? It seems that you understand, but it's not. So the only way to pass is check whether you can solve the problem or not. If you still cannot solve the problem, then you need to find which one that I have been missing out, which content. Because I think the university level is different from the high school. In high school, they are already set the curriculum, blah blah blah, and then you are coming class and get the maybe your teacher say something, blah 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 blah. But in university level, the students need to be independent. Okay, so the responsibility is on your own hands. Okay, you need to check which part that you have been missing out. Maybe you could ask, if you already know, maybe you could ask your TAs, ask your tutor, or maybe ask me if I have time, and then we can discuss together. Okay? Okay, we can start. For number 1, I think it's quite simple. Why writing 3? How we can get this 3? No. So remember that in calculus we need to take steps one by one. Do not like mix up everything inside one. Like you want to answer like getting the answer there. It doesn't work like that. So as I mentioned, if you think that maybe the function, maybe it can be more complicated than this. Sometimes you simplify your own notes. I just write this as A. Okay. Or maybe any symbols you want. Like usually I draw a cat here. Okay, just to make sure that it can be anything, any variable A, B, C, it's okay. But what you want to do is, if we take this, any symbol, maybe A, and we know the A is a function, then if we derive this will be 1 over a, and don't forget to multiply a prime. Okay? So, this part here, dy dx becomes 1, and then put everything down, the very same function, and then we derive and multiply with the chain rule. Okay? Got it? Okay. So the more you are getting familiar with this, the more you are able to understand the logic behind the calculus. Okay? And then doing the same thing with this part. So we have dy dx. So put everything down here, sine x. And then we try to derive sine, which is cosine. We can write this as a cotangent if you want. But if you prefer cosine over sine, that's okay. How about the third one here? The third one, dy dx. Remember now, ln is inside. So the outside is a square root. The square root, maybe if you are not familiar, you could start by taking this square root of x like that, and maybe taking x with power of half, okay? And then we derive this. It's become half x, half minus 1, which is negative 1 over 2, which is, we can write as like this, okay? Right? So, the part here is 1 over, write everything with 2 square root of the ln x, multiply the derivative of ln x, which is the 1 over x. Okay. So everything in I think, from the techniques that you have been given, they are all patterns. Okay? So once you learn the pattern, all the questions, if you are maybe see any complicated function, you are still able to do it. I guarantee you. Okay? So, and again, in calculus, especially in the exam, it's not about the result. It's not about the number, but your process. How to get the process, the steps, the pattern. That will be more important. So if you are writing the exam, and then you are not providing any maybe good understanding in the process, but somehow you get the number, oh, this is 3, this is 2, this is 0, then maybe you will not get much points. Okay, any questions? These 3 examples? Anyone still having a problem with the chain rule? Okay. How we get the next thing? Oh, it's a slide there. Okay. Okay. Any questions? Yeah. The number 2? Yeah. No. If you stop here, it's okay. Okay, now another example, another type of problem for the ln, since ln is actually, you combine the implicit and an ln, your whole understanding of how to use the calculus to solve the derivative will be much improved. Okay. So let me tell you the one way to solve. Okay. So find dy dx of let me make a bracket here to make sure that it's inside.
And you will see that the interesting part on calculus techniques, integrations, derivative, differentiation, that there's not only single way. You can choose several ways. Depends on your preference. You can choose which method you prefer. Okay, so ln, if you see the pattern from the previous part, you can do that as well. So we can 1 over all this, which means we are going to switch, right? And then multiply with the derivative of this, which takes time, I think, but it's still doable because you can do that as well.
So first is we can take the dy dx and then write this as, let me just write this in terms of like x plus 1, like that, and then derive the inside function, which is x plus 1 okay.
So the method is more to directly using calculus method, okay? And then you get some part here. You can use the quotient rule, blah blah blah, right? But it takes time, right? So what I prefer, if you agree, then it's okay. What I prefer is I will arrange the structure first because we know the logarithmic. This is the log. I will rearrange this. Okay.
In terms of, so if we have ln and then we multiply with inside is ab like that, we can take this and plus like that. If we have a over b like this, then we have ln a minus ln b like that, right? So this case,
We see a fraction, right? We see a over b. So we can separate, becomes 2 log, okay?
so we can write this as ln x plus 1 minus ln x minus 2 like that.
And then if we differentiate these two, maybe much easier. Right? Okay. So you can have a choices. You can directly derive, or you can arrange the structure and then derive.
So we can derive this. Let me write. So this will be 1 over x plus 1 minus, this will be 1 over x minus 2, and then multiply with 1 over, I hope you understand what's happening here. So we have minus
first part for the square root, this is because of the ln, and the second part is because of the chain rule. The square root becomes one of the two square roots actually. For me, if you get this, then okay. If you want to combine and then write another form, it's okay, but wasting time, so just stop here. Yeah.
Can you explain square root x minus 2 is the derivative of?
The square root of x minus 2.
Okay, and where is the?
Wait.
Oh, what happened? Oh. Wow, 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 wow. Why? Oh, trouble. Okay. Somehow it turns back. I don't know how and why.
So,
The x plus 1.
so
In here.
ln x plus 1 by chain root it will be
1
over x plus 1 times
chain rule of
times 1.
Yes.
Okay, so okay.
Yeah, any other questions in this part?
Okay, so this part here, again, like usual, if you feel maybe you need to simplify this with a, then you can write ln a becomes 1 over a and then multiply with a prime. Okay? So the whole thing here, the square root will be going down.
And the a prime is this. Is this derivative of the square root of x.
Yeah.
Here we have to vary like ln, and it's like 1 over x.
Yeah.
But we have to like do also like
X plus 1. Yeah.
But this is just 1.
Yes,
That's
correct.
what you did
Correct.
with
Yes,
math.
yes.
I was like screaming because I wasn't
Yeah.
finding it.
Oh yeah. Correct. Okay, let me give you some additional information on how the ln and the implicit differentiation can also help us to, let's say, if you forget some formula from the derivative, the implicit differentiations and the ln, the log will be helpful. Okay. So let me explain here, just for a while. So we take the y(x) with power of n, right? We know this derivative, right? We can derive this, but if somehow we need to prove this, let me get you the idea. If we add both of these left and right sides, we add with the ln. We can do that, okay? We can do that in math. Okay?
If we take the ln on the left, we need also to take ln on the right side, which means that we are now having a logarithmic equation. Okay. Now, in log, you have we have power inside. Those powers we can move to the front. Okay.
Okay, if you are not really covered much on logarithmic, and if you are in my basic math, I will cover that later on. Okay, but the idea is every time you have this, you could rewrite this and make it into ln x like that. Okay, and then if you want to derive this, okay, if you want to derive this using implicit differentiations, okay, you could somehow, using the same logic as we mentioned previously, so everything inside the ln becomes reciprocal, becomes, if it is ln y, it's become 1 over y. Okay, so it will be 1 over y. But remember, it's implicit, then we need to add dy dx. Okay, and then this part, since n is just a number, a constant, then we could just focus on the ln x. So this will be n 1 over x, like that. And then if you want to write in terms of dy dx, we can write n multiply with 1 over x multiply with y. Okay, and what is this is actually, remember that
We define y is actually power of n. Okay.
so we get that this will be so n 1 over x and then x with power of n, which actually
This 1 over x is actually power of negative 1. So we can combine these two. So we are getting
our original power rule formula. Okay, so we get
and for most of the cases, like when you deal with some functions that has exponent, for example,
maybe something like if you deal with maybe you have a y equal x plus 1, and then you have a power of x squared plus 2x plus, maybe it's 2x, too much.
how to solve this? One way to solve it is adding ln and then move the top equation to the front. That's one way. Okay? And then derive.
So we can take this, taking the ln y, and then ln, and then put everything inside here. So x plus 1. This is actually a random function that I just made up, so I don't know whether this is valid, but let's say it's valid. So the idea is we are taking this and then forcing the power to come down and make it this part. Okay, and then you can derive this. Oh, of course, this will be complicated because I don't know this function because I just randomly write.
But the idea is you are going to have the power coming down because it has a variable. So the ln will help you to make sure the equations looks normal, and then you can do the other methods as well. Okay. I think it seems that if you think this is one function, this is another function, you can do product rule. No problem. You can do product rule.
maybe making bracket here to make sure that they are. Why? Okay. Maybe the problem is the cable. Okay, any questions? Okay, one important thing about the ln. Okay, one important thing about the ln is if you have the absolute value. If you have absolute value. So let me write just a little bit notes, okay, before we end the class. So if this will impact fully related to your understanding later in integration. Because if you have learned before the integrals of 1 over x, you need to write ln with absolute value. Right? If you forget this absolute value, it's really wrong. Okay. So first we need to decide the interval. Okay? You remember the absolute value, it has like that, right? So it can be negative, it can be positive. So here we can treat the functions similar to that. So we can write the functions and then write a piecewise definition. It can be x or it can be negative x, right? This if it is a positive, and this if this is a negative. And I'm not equaling it to 0 because it will be undefined. Okay? So the derivative for this two will be first is 1 over x for the positive x, and then the second one will be, what will be the result? ln having negative x inside. So do the same thing, 1 over negative x. Multiply with the chain rule, negative 1. Negative, negative, positive. Agree? Agree? Okay. So let me write maybe here 1 over negative x. This is negative 1, so this will be 1 over x. So they both get the same result. That's why when you reverse this to make the integration, you need to take the absolute value. So we can write the f prime x is 1 over x for all x except at 0, because we know that it will be undefined. So if we try to squeeze into one graph, okay, this is the ln. This is ln x. This is ln negative x. And then this part here is the 1 over x. 1 over x has a 2 curve, right? So the other one will be here. So within the same functions, it has 2 curve. Maybe not really proportional, but I hope it's okay. Okay. So this will be a 1 over x. It's 1 over x. And I think you could easily see from the log, if you remember, what will be the slope for each point.
So it's going up, but it seems that so it's positive, right? Positive slope, but from positive it tends to be 0, so it's decreasing. You get it? So it's high. I think you want to apply it. So it's positive here, right? But it's decreasing. Okay? And the same way with this one, we see that this will be slope is negative, and then from 0 it's become more and more negative, which is decreasing, and then it's on the negative side. I'm not sure it's going to make into your mind, but I will repeat that later on. Just make sure about that,
Because I'm pretty sure that the last part I think maybe most of you don't get the point, but I will explain it later, I think. So I believe do we have maybe one questions example here, just to finish off the class.
We have this and
Find the dy dx. Okay, fine.
just to try out what I've been mentioning before. Okay, try this one before we end the class.